Okay class, Assalamualaikum and good day. So today we will continue our lesson with Maclaurin theorems. It's still in chapter 3, which is power series. Before this, we have learned about Taylor's theorem, where by using the Taylor's theorem, we can find the expansion of a function in terms of fx minus a or fx plus a. Okay, so if we have a function in the form of fx minus a, okay, by using Taylor's theorem, we will get the expansion of this function as fx equal to fa, okay, plus with f prime a x minus a plus with f double prime a, don't forget to divide by 2 factorial x minus a to the power of 2 plus with f triple prime a divided by 3 factorial x minus a to the power of 3 plus with dot dot dot, because this one is the infinite series. Okay, and if we have the function in the form of fx plus a, the expansions by using Taylor's theorem will be as fx plus a equal to fa plus with f prime a x plus with f double prime a divided by 2 factorial x square plus with f triple prime a divided by 3 factorial x cube plus with dot dot dot, because this one is infinite series. Okay, if the question asks you to find the expansion until the fourth term, this one is counting as the first term, this one is counting as the second term, this one is the third, and this one is the fourth one. Okay, so if the question asks you to find the expansion until sixth term, then you can continue this series, because this one is the infinite series. You can see that when we have the third derivative here, we will divide by 3 factorial here, and the power of the series is 3 now. Okay, and if we have the 2 derivative here, we will divide by 2 factorial, and the power of x minus a is equal to 2. Okay, so it will still in this pattern. So now let's say we assume the value of a here is equal to 0. Therefore, from here, we will get fx is equal to f0 plus with f prime 0x, okay, plus with f double prime 0 divided by 2 factorial x square plus with f triple prime 0 divided by 3 factorial x cube plus dot dot dot. This one is called as a Maclaurin's theorem, where the Maclaurin theorems is when the value of a is equal to 0. Okay, therefore, because of the Maclaurin theorems happen when the value of a is equal to 0, we have a few of pattern for expansion here. Okay, so you can refer this table whenever you want to find the expansion of the Maclaurin series for sin x, cos x, exponent x, 1 plus x to the power of n, 1 minus x to the power of negative 1, and also the ln 1 plus x. Okay, so this one is the expansion of the function by using the Maclaurin series. Because Maclaurin series happen when a is equal to 0, therefore we have this form of expansion. For example, if we have sin x, the expansion of sin x by using Maclaurin series will be x minus x cubed over 3 factorial plus with x5 over 5 factorial minus with x7 over 7 factorial. So what you can see here, for sin, okay, it will start with x, then the power will be odd number. Okay, the power is 1, the power is 3, the power is 5, and this power is 7. And for cos x, why it start with 1? Because it's actually x to the power of 0, even number. Okay, so x to the power of 0 is equal to 1, therefore it start with 1. Then you have all the even number here as the power, therefore you will divide by 2, 4, and 6 factorial. That is the way how you can remember this form of Maclaurin series. Okay, but you always can check or can refer to this table. Alright, and this one is the expansion if it involves the function of exponent. Okay, and this one is for 1 plus x to the power of n and this one is for ln 1 plus x. Okay, so let's see example. We want to use the Maclaurin theorem to expand ln 1 minus 2x over 1 plus 2x to the power of 2. Okay, so before we can use the Maclaurin's theorem, you need to use the law of ln, okay, for this function, where we know that when we have two different functions with the sign divide here, it can be written as ln 1 minus 2x minus ln 1 plus 2x to the power of 2. This one is by law of ln. And if you can remember, if we have plus, for example, ln 1 minus 2x plus ln 1 plus 2x square, what will happen is the function will be multiply 1 minus 2x multiply with 1 plus 2x squared. Alright, so because we have now the operation division, therefore it will be minus. Okay, so what we will have is ln 1 minus 2x minus with ln 1 plus 2x to the power of 2. So now if you can remember, okay, when we have ln and the power behind here, we can bring this power to the front. Okay, so what you will have here is ln 1 minus 2x minus with 2 ln 1 plus 2x. So now we want to find the expansion of ln 1 minus 2x and also the expansion of ln 1 plus 2x. Okay, so you can refer to the table. What is the expansion of ln 1 minus 2x? So if you can see here, it will be ln 1 plus x. Okay, here must be 1 and plus x. Therefore, whatever you have at behind here will be your x. So let's note that your x is equal to negative 2x. Alright, so now when you want to find the expansion of ln 1 minus 2x, you will use this expansion, but you will replace your x with negative 2x, because now you have your x as your negative 2x. So what you will have for this one will be negative 2x minus with negative 2x to the power of 2 over 2 plus with negative 2x to the power of 3 over 3 minus with negative 2x to the power of 4 over 4. Okay, plus with dot dot. This one is for the first function here. Alright, and then we have minus 2. Okay, you have 2 here, and you need to find what is the expansion of this ln 1 plus 2x. Okay, so you see here, you must have the function in the form of ln 1 plus x, but now you have 1 plus 2x, means that your x is actually 2x. Okay, so let's note your x now is actually 2x. So what you need to do is you will use this expansion, but you will replace your x with 2x. Okay, so you will have 2x minus with 2x to the power of 2 over 2 plus with 2x to the power of 3 over 3 minus with 2x to the power of 4 over 4. Okay, plus with dot dot. Alright, so now you can simplify your function. If you can see here, okay, negative 2x square, okay, negative 2x square will give you positive 4x square. So negative 4 and 2, you will get negative 2x square for this one. Okay, then you have here negative 2x to the power of 3 will give you negative 8x to the power of 3 over 3. So you have your third term here. And then here you will have negative 2x to the power of 4 will give you 16x to the power of 4 over 4. So 16 over 4 is negative 4. Okay, negative 4x to the power of 4. Right, so this one is for the first one, and then we expand the second one here. So negative 2 multiplied by 2x, you will get negative 4x. Okay, so here you will have 4x squared divided by 2, so you will have 2x squared. Here you have minus, don't forget. Negative 2 multiplied by negative 2x squared will give you positive 4x squared. Okay, and then for here, you will have 8x cubed over 3. Negative 2 multiplied by this one will give you negative 16x cubed over 3. And the last one, okay, you will have 2x to the power of 4 will give you 2 times 2, 4 times 2, 8 times 2, 16x to the power of 4 over 4. You have minus sign here, okay, and negative 2 multiplied by this one will give you positive 16 over 2x to the power of 4. So positive 16 divided by 2 is positive 8x to the power of 4. Alright, so now what you can do is you can simplify this equation, okay, by combining them. So what you have here is, we start with the highest power, negative 4x to the power of 4, okay, plus with 8x to the power of 4 will give you positive 4x to the power of 4. Then you have negative 8 over 3 to the power of negative 8 over 3x to the power of 3 minus with negative 16 over 3x to the power of 3 will give you negative 24 over 3x to the power of 3, which equal to negative 8x to the power of 3. Okay, then you have here negative 2x to the power of 2 plus with 4. Negative 2 plus 4 is 2x to the power of 2. And the last one is negative 2x minus with 4x will give you negative 6x. So this one is the expansion of this function by using Maclaurin theorems. Alright. Okay, let's see example number 2. By using Maclaurin theorems, expand exponent 2x plus exponent negative 2x over exponent x. So if you refer to the table of Maclaurin series here, okay, what you can see is only the expansion of the function exponent x. Okay, so we don't have any complicated form of the exponent x. We only have the expansion of exponent x, which is 1 plus x plus 1 over 2 factorial x squared plus 1 over 3 factorial x cubed. Okay, let me write it here. So by Maclaurin theorem, the expansion of exponent x will be 1 plus x plus, okay, 1 over 2 factorial x squared plus 1 over 3 factorial x cubed plus with dot dot dot. So this is the expansion of the exponential function, okay, by using the Maclaurin theorem. So now what you want to find is the expansion of this function. Okay, so before we can find the expansion of this function, let's see how can we simplify this equation. So you have exponent 2x plus exponent negative 2x divided by exponent x. And for your information, you can separate both of them. Okay, give them a denominator, each one of them. So what you will have is exponent 2x divided by exponent x plus with exponent negative 2x divided by exponent x. Okay, it same goes like if you have like this 4x plus 3 over 2. Okay, contoh dia awak ada 4x tambah 3 over 2. So awak sebenarnya boleh pisahkan. Okay, bagi dia orang seorang satu denominator. So apa yang awak ada adalah 4x over 2 plus with 3 over 2. Right? So same goes to this function. So now when we have given them each denominator, so we can simplify. Because now you have exponent 2x divided by exponent x. So when divide, the power is minus, right? So what you have here is exponent 2x minus x will give you x. Okay, plus with exponent negative 2x divide by exponent x. So when divide, bila bahagi, power dia kita tolak. So negative 2x tolak x will give you exponent negative 3x. Okay, so now instead of you have a division function that consists of divide, you only have a single function of exponent here, which is exponent x and exponent negative 3x. Okay, so you can find the expansion for each of them. The first one, you need to find the expansion for exponent x. Because kalau awak tengok, yang ini form dia sama je macam yang ni. Okay, so kita ambil je terus expansion dia adalah 1 tambah x. Okay, so the first one, expansion dia akan jadi 1 tambah x tambah 1 per 2 factorial x square tambah 1 per 3 factorial x cube tambah, saya nak teruskan ke 4, 1 per 4 factorial x4. So this one is for the first one. Then you plus with the second one. So now the second one, kalau awak tengok, dia tak sama macam this one. Okay, so kalau awak tengok, x ni adalah sebenarnya negative 3x. Okay, so x adalah negative 3x. Let's note it. X is equal to negative 3x. So untuk awak dapatkan expansion untuk the function yang kedua ni, semua x dalam expansion ni awak kena tukar dia jadi negative 3x. So apa yang awak akan ada kat sini adalah 1, okay, plus negative 3x. So plus dengan negative 3x plus with 1 over 2 factorial. So gantikan dengan negative 3x square plus dengan 1 over 3 factorial negative 3x cube plus dengan 1 over 4 factorial negative 3x 4 plus dot dot dot. So this one is for the second function. Okay, sebab sekarang awak tengok yang ini adalah dia punya Maclaurin theorem punya expansion. Dia punya x dekat sini. Sekarang kita ada x kita sama dengan negative 3x. So kita gantikan semua x ni dengan negative 3x. So kita dah ada dah expansion untuk kedua-dua function. So tugas awak adalah untuk awak permudahkan ataupun simplify. Okay, so daripada the first one ini, okay, so kita senaraikan, kita ada 1 plus x. Okay, 2 factorial adalah 2, so awak ada tambah dengan x kuasa 2 per 2. Lepas tu 3 factorial adalah 6. So awak ada x kuasa 3 bahagi 6. 4 factorial adalah 24. So awak ada tambah x kuasa 4 per 24. So ini untuk function yang pertama. Okay. Then kita tambah dengan function yang kedua. So kita ada 1 minus 3x. So this one, negative 3x kuasa 2, awak akan dapat positif 9x kuasa 2 per dengan 2 factorial adalah 2. Okay, tambah dengan negatif 3x kuasa 3, awak akan dapat negatif apa? 3 kali 3, 9 kali 3, 27. Negatif 27. So positif dengan negatif akan jadi negatif. So awak ada negatif 27x kuasa 3 bahagi dengan 3 factorial. So 3 factorial adalah 6. Okay, tambah dengan, okay, negatif 3x kuasa 4. Negatif 3 kuasa 4 adalah positif 81 x kuasa 4 bahagi dengan 4 factorial adalah 24. So ini adalah untuk equation yang kedua. So kita tengoklah yang mana kita boleh simplify. Okay, so this one x kuasa 4 dengan x kuasa 4. Okay, so 1 per 24 tambah 81 per 24, awak akan dapat 82 per 24 x kuasa 4. Then we have positif x kuasa 3 per 6 tolak dengan 27 per 6x kuasa 3. So 1 per 6 tolak 27 per 6, awak akan dapat negatif 26 per 6 x kuasa 3. Okay, 26 per 6 x kuasa 3. Okay, dan 1 per 2 x kuasa 2 tambah dengan 9 per 2 x kuasa 2 will give you 10 over 2 x power of 2. So you have 5 x power of 2. X tambah negatif 3x akan bagi awak negatif 2x. Dan 1 tambah 1 akan bagi awak 2. So this one is the expansion of the function bila kita dah simplified. Alright. So let me see why here is negative. I think it's wrong here. It should be positive because, okay, if you can see, this one is positive, and this one is positive, and positive will give you positive, because negative 3 to the power of 4 will give you positive value. So this one should be positive. Right? So this one is just simplify. 82 ni kecilkan, awak dapatlah 41/12. 26 dengan 6 kecilkan, dapat 13/3. So this is how you find the expansion of the function by using the Maclaurin theorems.